Good day, everyone. My name is Johan Plessis, and together with my colleague Andrew Brooks, we will be presenting Procon's contribution to the BIM Harambee Africa virtual conference. Procon primarily develops structural engineering software, as well as being an Autodesk accredited developer. The company is making great strides in developing software suitable for the age of BIM. Our goal is today to show this to the audience. Every structural engineer will at some point in their career use one of the three popular packages developed by Autodesk, namely Revit, Advanced Steel, and the tried and trusted AutoCAD. The Procon suite of programs offers powerful analysis, design, and detailing programs. Sumo is our primary analysis tool and will be at the center of today's discussion. Our various design modules can be used to ensure that your designs are code compliant. Probot 2D is an add-in for AutoCAD, which can be used to detail reinforced concrete in AutoCAD. Another program at the center of today's discussion is Prodesk, also developed by Procon. This is an add-in for Revit and Advanced Steel, which allows us to communicate with Procon software. Prodesk gives you the ability to export and import models between Sumo and the Autodesk packages, and you can load rebar designed in Procon. All of this will be demonstrated today. The analysis and design portion will be done by Andrew. At the end, I will show you the functionality that Probot 2D offers. We'll also have a quick look on what you can expect from Procon in the coming months. Over to you, Andrew.
Here we are in Revit, where many projects nowadays have their origin. In most cases, an architect will create a structure that a structural engineer must design. We want to use the already existing structure in Revit to do an analysis for design purposes as quickly as possible without having to redo a bunch of work. Luckily, with Prodesk this is possible. Prodesk is developed natively in Revit and doesn't rely on any Exchange file formats. Rather, the intelligence inside Revit is extracted and loaded into Procon's flagship analysis program called Sumo. Of course, there will be some preparation work to be done in Revit. The most important concept to consider is that Prodesk relies completely on the analytical model in Revit. This is ultimately where the geometry is generated from. It is therefore important to consider the analytical model when creating a structure. The next consideration is the section mapping. Since Revit families can be created with any type of name, Procon needs to be made aware what section is supposed to be used. However, the section mapping information can be saved in a separate database and reused or distributed between colleagues. You will also notice that I am using Procon families. The reason why I can do this is because Prodesk allows me to use Procon's section database to generate Revit families from custom sections. Any reasonable two-dimensional shape can be drawn and loaded into the section database, after which a Revit family can be created. The section database is completely customizable and already supports several countries by default. To use Prodesk, you will access the Procon ribbon in Revit, which contains Prodesk's functionality. Let's dive right in. I'm going to select all the elements in Revit, just drag my mouse across here. Now I can use the Import-Export button to export data to Sumo. Let me point out just one very nice feature that Prodesk has. I have several walls on the top floor which were defined as non-structural or architectural walls. We don't want these walls to be transferred as load-bearing walls, They must rather be seen as loading. Prodesk will convert the architectural walls into line loads based on the wall's material and geometric properties. You can also see that I have predefined my section mapping, so Sumo will know what section to use for the analysis. After saving the Sumo file, it is opened and we can see that the structure was transferred. Immediately, we can see that the architectural walls have been converted into line loads. We can also see here loads defined in Revit are loaded into Sumo as well. Let's assign the structure self-weight to the dead load case. The first thing that I like to do is to select all the pad footings. I can select all the elements and use the filter. Sumo doesn't assume any fixity, but expects the user to define the support conditions. While we are working with supports, I will add an area support for the retaining wall base and a line support below the ramp. Although we receive the dead and live loads from Revit, we can add our own loads as well. Let me show one of the loading function that Sumo has, the wind load. Let's add a wind load case. First, we can define which loading code to use and enter any location-specific parameters. Next, we draw the area that must be loaded. The nice thing about the wind load is that although the magnitude is calculated automatically, we remain in control over which elements must be loaded. The area load is then automatically transferred to the loaded elements. Of course, now fewer manual calculations are needed as well. I can also copy the defined load to different positions using CAD commands that we all know very well, such as this linear copy. Let's shift our focus to the analysis of the structure. Sumo is, after all, a BIM modeling and analysis tool. To analyze concrete slabs and walls, we rely on finite element analysis. To allow this, we need to have our elements broken into smaller pieces. One of Sumo's defining features is automatic surface meshing. With a click of a button, we can mesh all the shell elements. The default mesh size is 1 meter. However, we can easily change that and redo the mesh. What about modifications to existing elements, you ask? One of the elements that is received when we use the Prodesk function from Revit is that we get the levels that are defined in Revit as well. Sumo can use these levels to force the program to work in 2 dimensions. When we have to create or modify a slab, it is usually much easier to work in 2 dimensions to make sure that we remain in the same plane. Making adjustments to existing elements are easy thanks to the CAD nature of Sumo. Let's remesh the changed slab so that we can do the analysis properly. After the meshing process is complete, we can do the analysis. Sumo is able to do a wide range of analyses, including second order, nonlinear, and also dynamic analyses. I will stick to a simple linear analysis in this example. After completing the analysis, we can view the results. The first set of results are the deflections. We can immediately see that we will have to make some changes to the cantilever above the ramp. Let's go back and make a few changes. I can extend the retaining wall as well as the retaining wall's base, and also the area support. And then copy one of the columns across to support the free corner. Now I can redo the analysis and the results look much better. When we view the results for the reactions, the area support will calculate the pressure based on the loads being supported. Sumo is database driven, which means we can easily use simple database queries to extract the necessary information from the list of results. I can, for example, view all the results in the combination C1, which is larger than some value. This helps with the filtering of the massive amounts of calculations that Sumo does. The output can also be exported to Excel. The BIM results display the axial forces, bending moments, and shear forces for all the beam elements. If you want to view a detailed graph of a certain beam, and also for a certain result, the charts allow us to do just that. We can click on the element that we want to view in the charts, select the result that we want to view, and the results for all the load cases will be plotted on a graph. The shell results show the results of the finite elements and contain three sets of sub-results. There are membrane or in-plane stresses, plate or out-of-plane results, and reinforcement for the concrete elements. Cast your focus on the middle slab, which is on elevation 9 meters. We will use the results for the reinforcement in this slab a bit later when we concentrate on detailing. Now that we have the results for the analysis, let's focus a bit on the design of individual elements. Although Procon has several individual modules that can all be used independently, the true power lies in the interaction between the different programs. We can use the results that we just viewed to do the design of individual elements by simply exporting the results to the design programs. The ribbon shows the number of designs that Procon can do based on the results from the analysis. Our structure contains a steel roof, so we will use both steel member design programs to design the trusses and the columns. Different steel connections can be considered. The modules are subgrouped into moment and shear connections. Concrete elements can also be designed, such as flat slab subframes, columns, and bases. However, Sumo goes a step further and is able to design a group of elements, such as concrete bases, and update the structure based on that design. I will define two design groups, one for columns and one for bases. I will load a small selection into the design groups to show how this works. First, the columns. When I click on Design, the rectangular column design program is opened. The geometry, as well as the loading that was calculated, is transferred into the design program. The design shows that a high percentage of reinforcement will be required. Therefore, I will update the section size. A 400 by 400 millimeter squared column ought to be sufficient. A bending schedule is automatically generated, and when I exit the design module, Sumo notices that changes have been made to the structure and asks to update the structure. Since a change was made, I need to redo the analysis. The same can be done with a concrete-based design. Although there is an optimize function, it tends to take a little while with a large number of load cases, so I will change the sizes myself. When I go back to Sumo, the bases are updated. Let's assume that we needed to make changes to the steel trusses as well. The top and bottom chords have been determined to need channels. I will replace the original T sections with these channels and save the file. Now that the design is complete, I can return to Revit to update the original structure. We have made a couple of changes and need to update the original information accordingly. I can simply use the import Sumo function. I won't include loading in this transaction. Our notification window shows that there is an error. Why would that be? Well, it tells us that there are differences between the materials we have in Revit and that we had in Sumo. I could, of course, have defined my own materials in Revit to be used instead of using the default materials in Revit. But it is nice to know that Prodesk warns us against such differences. Yes, the marks are the same, but this is not the end of the world. I can click on OK there. The important thing is that the structure has been updated. The retaining wall has been extended. Columns and bases are larger, and the top and bottom chords of the truss have been updated to channels. A nice round trip for analysis and design using Prodesk, Sumo, and several other design modules from Procon.
Thank you, Andrew. Now we get to the detailing portion of this presentation. Probar 2D is an add-in developed by Procon that gives reinforcing functionality to AutoCAD. Once installed, a Probar 2D ribbon will appear. A bar drawn with Probar is not just a polyline, it is an intelligent entity. For example, a bar drawn can be modified in the Properties palette and will be updated in the schedule. The diameter of a bar determines the bend radius, and this gets updated too. You will see that the bar in the drawing space updates as I change the bar dimensions. The scheduler reads all the rebar entities in the drawing, and it can be published with bending dimensions and a weight summary within a custom title block. As you can see, detailing rebar by hand is definitely a thing of the past. Detailing a slab designed in Sumo is quite easy in ProBar. I can use the Sumo wizard to import the required reinforcing contours to AutoCAD and can then use the Rebar Calculator to arrive at a suitable bar diameter and spacing. The process can be repeated for every bay and every layer of steel. Looking at the area of steel required in the Y direction in the bottom layer, in the X direction, the contour plot shows me the different steel requirements in different regions of the slab. I usually draw some construction lines to separate the different regions. Let's go ahead and add some reinforcing. I can now go ahead and use the Rebar Calculator to determine the required reinforcing. The program tells me that a Y20 bar spaced at 250 millimeters is enough. Expanding the bar groups, there are a number of wizards that can assist you in detailing other elements designed in Procon. I will detail the column as well as the base that Andrew designed earlier. Probar 2D gives me an elevation of the column as well as a cross section. A schedule can be generated for the rebar in the drawing. Loading the base file that Andrew created. What we've demonstrated today is a recommended workflow that we advise clients on. Each design office have their own way of doing things, and our software should slot seamlessly into yours. Looking ahead at what you can expect from us in the future, we are moving toward implementing our 3D rebar functionality in Revit. This will allow you to import 3D rebar designed in Procon. We are implementing Python scripting in Sumo. This will allow advanced users to automate some of the boring tasks and make Sumo even more powerful. We are working on a number of new design modules, most notably composite beam and column design, as well as an anchor bolt design program. And that concludes our presentation for today. Thank you for your time.